reflections. Objective by NS lesson, you should be able to graph functions using reflections, apply reflections to given points to find new coordinates. So we're going to have two types of reflection. For y is equal to negative f of x, then what we do to f of x is, well, inside opposite, outside follow. This is on the outside, so what you do is we multiply our y values by negative 1. And if you do that, it flips it up. If you multiply your y values by negative 1, then it flips upside down across the x-axis. So this is called across the x-axis, also known as the x-axis flip. I personally call it a vertical flip, because that's what's happening. If you multiply your y's by a negative, then you're going to flip it vertically. It's going to flip across the x-axis, but it's going to be a vertical flip. Look at the inside one. When it's negative on the inside, that affects the x values. Inside x opposite. So remember, we're going to do opposite operation, so we're going to multiply our x values by 1 over negative 1, or divide our x values by negative 1. And when that happens there, you flips all your x values, so it flips horizontally. So I call this, some people call it a y-axis flip. I call it a horizontal flip. And again, doing what we normally do, all you do is multiply our x values by 1 over negative 1. Or divide by negative 1. So that's it. Let's do a couple examples here. So consider the graph y equals f of x alongside. On separate axes, draw this. So they want us to draw y equals negative f of x. So again, two ways to think about it. If you know what it looks like, then it's like, oh, it's on the outside. Outside affects the y. So this is a vertical flip, also known as an x-axis flip. So I'm going to flip it upside down. So if you're good with doing that, it's going to look something like this. A little off. Kind of like that. Again, my art's not the greatest, so I do this. So that's pretty good, right? That's what will happen. Another way to think about it is just get points. This is 0, negative 3, 0. Helps if you're good at math. Negative 3, 0. This is 0, 2. And this is 3, 4, looks like. Right, so we have negative 3, 0, 0, 2, and 3, 4. And all I'm going to do here for my graph on this one, let's do it in blue actually, so I'm going to multiply my y by negative 1. So I'm going to get negative 3 and 0, 0, negative 2, and 3 and negative 4. So that point stays 0, negative 2, and then 3 and negative 4. So again, you gotta try to match the curve, but it looks like that. So that's what happens when the negative's on the outside. What happens if it's on the inside? Right, inside x opposite. In this case, that means we're gonna divide or multiply by negative 1. Multiply by 1 over negative 1. Same thing. So I call this a horizontal flip. And again, if you're good with the flips, you can just do a horizontal flip. So it's going to flip over there, that's going to flip here, that's going to flip this way. So it's going to look kind of like this. And you get a horizontal flip. You can also use the points. Right? And all we're going to do here is multiply our x values by 1 over negative 1 or divide them by negative 1. Any way you want to think about it. So I get 3, 0, 0, 2, negative 3, 4. 3, 0, 0, 2, negative 3, 4. And again, just trying to like match the curve. So it's an inside effect. A little off there, but general idea. Okay, next one. Find f of negative x of this thing. So based by looking at it, I know, oh, this is a horizontal flip. It's on the inside, affects the x. So it's my graph left and right. Whatever my graph is, it's left and right. But how do I simplify this? Well, you just do what it says. Substitute x for negative 1. Negative x, sorry. If you want f of negative x, whatever's an x, just substitute in negative x. Now here, negative x squared gets me just x squared, because you square it negative. Over here, you're multiplying negative x times 2, so negative 2x plus 1. So that'll be the horizontal flip of this graph. Next one, they actually want you to graph the two. So remember, we don't do a special graph, just do a basic graph. And the easy way to find the basic graph is to find the vertex. So x equals negative b over 2a. Or you can factor it too. That works. I'm over here. So negative 2 over 2 times 1. So I get negative 1. If I substitute it back in, negative 1 squared plus 2 times negative 1 plus 1 is 1 minus 2 plus 1. And we get 0. So my vertex is negative 1, 0. And then it is positive, so it opens up. So it looks like that. And then they also want me to graph the inverse. Now we already found the inverse up here, so we can just find the vertex of this one. Vertex equals negative b over 2a. Negative negative 2 over 2 times 1. So 2 over 2, which is 1. Substitute that back in. And I get 1 minus 2 plus 1. 0 again. So I get the vertex of 1, 0. So that's over here. If you look at it, right, it's a horizontal flip. Flips across the x-axis. So that's the general idea. Next one. The function y equals fx is transformed to g of x equals negative x. So they're just saying g is the negative, to the negative outside the f of x. Find the original of the point y equals g of x corresponding to the following points y equals f of x. So this is another one where this is an f. I want to know what g does to it. Well, what does g do to it? It just multiplies your y value by negative 1, right? If I see this, only thing that's happening is my y value getting multiplied by negative 1. So x is doing nothing. X does nothing. Y gets multiplied by negative 1. So the point negative 3, 2. All we're going to do is multiply our y by negative 1. We get the point negative 3, negative 2. That's all that happens there. Right, all we're doing is doing a vertical flip to this point, so that point comes from negative 3, 2 to negative 3, negative 2. So next one, similar idea. A function is transformed by the graph of this, and now it's doing a vertical flip and a horizontal flip. What combination of transformations is taking place? So we're going to say, we'll say a flip reflection, a horizontal reflection, and a vertical reflection. So you can say that. You can also say your x value gets multiplied by 1 over negative 1, and your y value gets multiplied by negative 1. B, if 3, negative 1 lies on the graph of this, transformation of the point y equals g of x. So it's the same thing we just did. If this point is in f of x, they want to know what point is in g of x. What are we doing? Well, what does g of x do to f of x? It multiplies the outside by negative 1, and it divides the inside by negative 1. Right? So inside divided by negative 1, multiplied by 1 over 1, negative 1. Outside times by negative 1. So we get the point negative 3, 7. Alright, so basically if I plug this function into this, that's what happens, right? Your x gets divided by negative 1 or multiplied by 1 over negative 1. And your outside gets multiplied by negative 1. C. Find the point on f that transforms to the point 5, negative 1. So this is going backwards. So in C, they're saying, hey, g of x has this point, negative 5, negative 1. They want to know what that point is on f of x. Right, so we're going backwards. Well, what do? We go backwards. So instead of dividing by negative 1, we're going to times it by negative 1. I get 5. And instead of multiplying by negative 1, we're going to divide by negative 1. And I get 1. So that's the point. Now if you plug this point into there, you get this point.